The Subcommittee on Energy will come to order. Without objection, the Chair is authorized to declare recesses of the Subcommittee at any time, and we expect votes to be called just any minute. Welcome to today's hearing entitled H.R. 4084, the Nuclear Energy Innovation Capabilities Act. I am going to defer my opening statement. I know the Chairman has graciously agreed to, and the Ranking Member has also, to be put in the record. So, good morning. Thank you all for coming. And I would like to thank Ranking Member Johnson, who's not here, and Chairman Smith for co-sponsoring this bill with me. It is an absolute honor to work with fellow Texans to establish policies that keep America globally competitive, support innovation in our economy, and actually promote national security goals. And I would also like to thank other original co-sponsors from this Science Committee. As the Energy Subcommittee's legislative business for 2015 draws to a close, we're going to be working on this stuff. You can read the rest of my statement in the record. And so with that, I'm going to introduce the witnesses. Thank you, Aaron. Our first witness today is Mr. John Kotek, Acting Assistant Secretary for the Office of Nuclear Energy at the DOE. Mr. Kotek previously served as the Principal Deputy Assistant Secretary for the Office of Nuclear Energy. In addition, Mr. Kotek, am I pronouncing that correct? Okay. Received his bachelor's degree in nuclear engineering from the University of Illinois and his MBA from the University of Maryland. I will now yield to the Chairman of the full committee, Mr. Smith, to introduce our second witness.
Thank you, Mr. Chairman. Our second witness today is Dr. Dale Klein, Associate Vice Chancellor for Research for the University of Texas System. 2006, Dr. Klein joined the Nuclear Regulatory Commission and was later appointed chairman by President Bush, where he served until 2010. As chairman, Dr. Klein was the principal executive officer and official spokesman for the NRC. He was responsible for the administrative, organizational, and long-range planning, budgetary, and personnel functions of the agency. Prior to joining the NRC, Dr. Klein was the assistant to the Secretary of Defense for Nuclear, Chemical, and Biological Defense Programs. He also served as the Vice Chancellor for Special Engineering Programs at the University of Texas and as a professor in the Department of Mechanical Engineering at the University of Texas. Dr. Klein holds a PhD in nuclear engineering from the University of Missouri. Dr. Klein, thank you for making the trip from Austin today, and we look forward to your testimony.
Thank you, Chairman Smith. Our final witness today is Mr. Ray Rothrock, Partner Emeritus of Venrock. Mr. Rothrock has had a career in venture capital spanning over 25 years, successfully investing in over 50 startup companies. Mr. Rothrock received his bachelor's degree in nuclear engineering from Texas A&M, his master's degree in nuclear engineering from MIT, and his MBA from Harvard. I now recognize Mr. Kotec for 5 minutes to present his testimony.
Thank you, Chairman Weber, Ranking Member Grayson, and members of the committee. Thank you for the invitation to testify at today's hearing. I appreciate the committee's interest in research and development of advanced nuclear energy technologies. The Department of Energy does not have a position on the legislation, but it is consistent with much of the work currently being done with by DOE. As has been noted before this committee in the past, nuclear energy continues to play a vital role in the President's energy strategy for a sustainable, clean energy future. Nuclear energy has provided nearly 20% of electrical generation in the U.S. over the past 2 decades and currently produces more than 60% of America's carbon-free electricity. As the U.S. leads the global transition to a low-carbon economy, the continued development of new and advanced nuclear technologies, along with support for currently operating nuclear power plants, is an important component of our clean energy strategy. Because nuclear energy innovation is at the heart of today's hearing, let me focus my oral remarks on DOE's research and development programs for advanced reactor technologies. Future generation reactor systems may employ advanced technologies and designs to improve performance beyond what is currently available. More advanced reactor designs with coolants other than light water, often referred to as Generation 4 designs, may enable reactors to operate at higher temperatures and with increased efficiencies. Continued R&D in this area is essential for the long-term prospects of nuclear energy. Advanced reactor technologies considered in DOE's R&D programs reside at different technology maturity levels, with R&D efforts mainly focused on 3 advanced concepts: liquid metal-cooled fast reactors, fluoride salt-cooled high-temperature reactors, and high-temperature gas-cooled reactors. DOE has also initiated studies on how to optimize the integration of nuclear energy and variable renewable energy sources through collaboration between my office and the Office of Energy Efficiency and Renewable Energy. These studies will not only examine integration of current light water reactor technology, but also advanced reactor technologies that have the potential to provide high-temperature process heat in addition to electricity. As noted in the proposed legislation, investments in the infrastructure to support advancement of nuclear technology are also critical. Research, development, and demonstration programs are dependent on an infrastructure of experimental and computational facilities, access to critical materials and data, and highly trained scientists and engineers dedicated to meeting the needs of the nation. The proposed legislation identifies 3 specific requirements for DOE to address in the areas of high-performance computing and supportive research, a versatile neutron source, and enabling nuclear energy innovation. NE programs are currently working across these 3 critical areas. The Consortium for Advanced Simulation of Light Water Reactors, or CASL, a DOE energy innovation hub centered at Oak Ridge National Lab, was established to provide leading-edge modeling and simulation capability to improve the performance of currently operating reactors. This successful program is now expanded beyond operating reactors to support modeling and simulation for small modular reactors. Additionally, our Nuclear Energy Advanced Modeling and Simulation program is addressing modeling and simulation needs for nuclear fuels and for advanced nuclear reactors. As these tools are developed and integrated, NEAMS will be able to provide nuclear technology designers with a truly predictive capability that spans from the fuel pellets to the entire plant to better predict the performance, reliability, and economics of advanced nuclear power plants. With respect to a new versatile neutron source, DOE is evaluating the potential need for a new nuclear research reactor capability. To support the development of advanced reactor technology options, the Department has undertaken a study to determine the needs of the advanced nuclear reactor community and to develop options, including the key features and timing for a possible advanced test or demonstration reactor, to support research, development, and demonstration and eventual commercialization of advanced reactor systems. And finally, with respect to enabling nuclear energy innovation, NE identified that improvements can be made to accelerate the innovation of nuclear technologies. To further enable this goal, NE launched the Gateway for Accelerated Innovation in Nuclear, or GAIN, during last month's White House Summit on Nuclear Energy. GAIN will provide the nuclear community with a single point of access to the broad range of resources, people, facilities, materials, and data, at our Idaho National Lab and across the DOE complex. Focused research opportunities and dedicated industry engagement will also be an important component of GAIN, ensuring that DOE-sponsored activities are impactful to companies working to realize the full potential of nuclear energy. Chairman Weber, Ranking Member Grayson, and members of the committee, thank you again for inviting me to discuss this legislation and the work that the Department and the Office of Nuclear Energy are currently doing. And I'd be happy to answer any questions.
Thank you, Mr. Kotek. We have been joined by the ranking member of the full committee, the gentlelady from Texas. You're now recognized for your opening statement, Ms. Johnson.
Thank you very much, and I apologize for being late. I knew the vote was coming, and I thought this would follow. On the Nuclear Energy Innovation Capabilities Act, which I'm very pleased to co-sponsor with you, and I'd like to thank our Acting Secretary of Nuclear Energy, Mr. John Kotec, for agreeing to be here today for such short notice, and I hope that our friends in the Senate will take that action away very soon. As I've noted before, nuclear power plays a vital role in providing our countries with clean, reliable energy. I live in an area where there's nuclear energy. Nationally, it produces almost 20% of our total electric power and provides 9% of the electricity generated in my great state of Texas, all with essentially no greenhouse gas emissions. But there currently are technical, economic, and policy challenges that prevent nuclear energy from playing a larger role in enabling our clean energy future. The Nuclear Energy Innovation Capabilities Act takes several positive steps to address these challenges. Implementing the provisions in this bill will help accelerate the development of advanced nuclear energy technologies that are safer, less expensive, more efficient, and produce less waste than the current generation of nuclear reactors. I look forward to this hearing from the distinguished panel that we have here today on any improvements that we can make on this legislation to achieve these goals. I'd like to express my appreciation for the process we followed to put this bill together. Majority and minority staff work closely together every step of the way, from engaging stakeholders through the helping to craft and incorporate suggested changes to build language. This is a great example of what we can achieve when we put politics aside and join forces to address the challenges facing our nation's research enterprise. I thank all of you for being here, and I'll yield back, Mr. Chairman. Thank you.
I want to thank the gentlelady from Texas, and when we opened, I said that I really appreciated you and Chairman Smith's co-sponsoring and helping with this bill, so thank you very much. Dr. Klein, you are recognized for 5 minutes.
Thank you. Chairman Smith, Chairman Weber, members of the committee, it's a pleasure to appear before you today, along with my colleagues, to discuss H.R. 4081. As a former chairman of the Nuclear Regulatory Commission, a fellow of the American Nuclear Society, and a research administrator at a major university, I applaud the committee for introducing this legislation, and I hope that it kickstarts a broader effort by all the relevant committees of jurisdiction to review and update federal nuclear energy policy. While I currently serve as the Associate Vice Chancellor for Research at the University of Texas System and serve on 2 utility boards, my comments today represent my views, not those of my employer nor the boards on which I serve. In order to understand the importance of this legislation, it's important to step back and appreciate the larger global context. Currently, there are nearly 2 billion people who still lack basic access to electricity, and many more access is unreliable. Add to that the increasing urbanization of the developing world with its attendant air quality issues, and finally the need to significantly reduce global carbon emissions, and you have what is perhaps the largest civilian technology infrastructure challenge in the world today. One thing is clear, any successful response to this challenge will be by necessity include a significant role in nuclear energy. And if the U.S. wants to exert its influence on safety, security, and non-proliferation, under which the global growth takes place, it must be a leader in nuclear technology. H.R. 4084 is an important first step toward aligning federal nuclear policies with today's realities, and if enacted, I believe will create a more collaborative relationship between the government and the public-private sector to advance nuclear science and public innovation. It is important to understand, however, that success will require other policy changes that extend beyond the jurisdiction of this committee. For instance, I believe it is inconceivable that any nuclear technology can achieve commercialization without the beneficial scrutiny of the Nuclear Regulatory Commission. I know that many may question my use of the word beneficial when you talk about the Nuclear Regulatory Commission. However, its role in protecting the public and the environment are fundamental to any successful nuclear energy technology. The NRC remains the best agency to address these requirements. I should note that the committee staff provided me with the July 2015 testimony by NRC Chairman Burns and of Mr. Todd Garvey, legislative attorney for the Congressional Research Service, concerning the authority of the NRC to address advanced reactor designs and licensing. After reading their statements, I was once again reminded why I became an engineer and not a lawyer. But I believe that there was agreement of the NRC has the authority and is fully capable of providing the review and guidance needed to support innovative technologies. The real question is, how do you provide funds to the NRC in order to carry out this activity? My second point is more of a cautionary note directed to my good friends at the Department of Energy, and where I encourage them to view this opportunity to change their approach to managing construction projects and public-private partnerships. I would encourage the committee to consider implementing guidance to Section 7 that would direct the department to identify governance approaches in addition to contractual mechanisms that would facilitate partnering with the private sector. My last point is that most nuclear projects today involve some level of international collaboration and foreign involvement. While continued U.S. competitiveness is an important issue, we must also recognize the benefits of collaboration. Therefore, we must be mindful of the restrictions and barriers that we have to international collaborators. I would encourage the committee to look at activities that would remove barriers with no loss to our national security goals. I hope that this legislation will provide Congress and the administration a common ground to rebuild our national security, science and technology, infrastructure, and reinvigorate the collaborative relationship between the government and the private sector. Thank you very much, and I look forward to your questions.
Thank you, Dr. Klein. Mr. Rothrock, you are now recognized for 5 minutes to tell us how to pay for this.
Well, let's start with some big checkbooks. Well, good morning, Chairman Weber. Thank you very much for this opportunity, Ranking Member Grayson, Chairman Smith, Ranking Member Johnson, and members of the subcommittee. I really appreciate you all introducing this bill, H.R. 4084, Nuclear Energy Innovation Capabilities Act. It's also nice to be among a bunch of fellow Texans. I appreciate that. This bill comes at a very important time in the history of nuclear power and clean energy, and I'm delighted to share with you today my experiences in the nuclear innovation ecosystem that exists in the United States and how this bill fits in that particular ecosystem. My journey to this table, I think, started when I was asked to testify how venture capital could assist in the Blue Ribbon Commission on America's Nuclear Future some years ago, which led to my co-producing the movie Pandora's Promise, which ultimately led to a handful of citizens getting together and addressing these problems. So why nuclear power now? Well, it would be quite irrelevant if it not were the fact that there are over 40 nuclear startups in North America now. Please cue the slide. As we began our journey across the country in the last several years, we discovered a very large group of startup companies, I said over 40, backed by $1.6 billion of private capital, not government capital, private capital. Third Way, based here in Washington, documented this more completely and presented this slide. The needs of these companies are all the same. They need patient investors with deep pockets, modern computational capability, nuclear-qualified laboratory space to prove their designs, and ultimately the approval of the Nuclear Regulatory Commission. The findings of these 40 startups was very exciting to us, and also was a surprise to virtually everyone we've talked to, including people in the government. So the entrepreneurs running these companies have all concluded that there is a need for a new reactor design to address many things that Ranking Member Johnson mentioned about economics, for example. I live and work in the Silicon Valley and have for nearly 3 decades, and I've witnessed from time to time the way to solve a problem is to get many people working on that problem, many innovators. And in the Silicon Valley, we call that many shots on goal. It provides not only competition, but it creates speed of solutions. And at the end of the day, we all win. Many shots on goal require lots of ideas, lots of innovators, lots of capital. And I would say that with the 40 startups we have in the United States, we're well on our way to having many shots on goal. But they can't do it alone. It requires a partnership with the government. For good and obvious reasons, nuclear development by its very nature and by law requires the government. None of these guys are going to succeed if they try to do this in the Silicon Valley or in a laboratory in New Mexico. It requires nuclear-qualified lab facilities, and this bill talks about bringing some of that capability to them. The national labs of our country are the finest in the world. I've visited many of them, and I've personally spoken to their leaders who are eager to assist, so your bill is well-timed. Also, I want to, in the spirit of a good signal to this community, congratulate the Department of Energy, the White House, at the White House Summit on Nuclear Energy, the GAIN program, which was just referred to by Mr. Kotek, and all his staff, was very well received from the community, and I've met subsequently with many of them. It's very compelling, it's very attractive to the private sector, but I will add this. After nearly 30 years of venture capital and having seen tens of thousands of business plans, with very ambitious goals, it is all in the execution, and so I look forward to helping and whatever I can do to help the Department of Energy execute the GAIN program. There is well, I'll skip that. Second signal, operating concepts of the Nuclear Innovation Facility. So I personally went out and surveyed as many of these folks as I could subsequent to being invited to speak here. And a couple of things to point out. This needs to be a very focused program. It needs to operate pretty quickly, so I would recommend a single point of contact for these private companies. They should all submit a work plan that's approved by whatever lab or whatever designated facility is created. They need to be able to pay for it, and they need to be able to prove that they can pay for it, which requires the teaming with the investors. There is an issue with the way national laboratories charge out some of their overhead. I've talked to several national laboratory directors about this, and I'm sure we can solve that problem, but I would recommend some sort of grant that's a non-cash kind of a grant, such as $1 of startup capital, $2 of government capital that gets into the accounting of it all. Don't mean to get into the details there, but it's something that needs to get sorted out, otherwise it'll just create more friction in the process. Intellectual property should belong to the company. The liability should be well understood as everyone goes into this. Everyone needs to be safety trained on health physics and other safety issues. Information sharing and consultation is very important, and I think embedding the NRC in the process will be a very important element as well. There's one question that comes to mind, and I'm nearly out of time, but quickly, there is confusion there is confusion out there. Can a startup company, even if they had the permission to use the DOE facility, can they build a reactor without the approval of the NRC on DOE property? This is a legal issue that was asked and answered years ago, thought resolved, but if you ask people in the system, they're very confused by it. So I just want to say in conclusion, I support this bill. I hope this and many others that will follow will put the U.S. back into a leadership position, has been suggested here. I thank you for this opportunity to testify, and we need to hurry. Thank you.
We need to hurry about this bill or about voting?
Yes.
Both. Well, we appreciate that, Mr. Rothrock. And we are going to recess. It'll probably take us somewhere around 35, 45 minutes, and then we will be back. We are recessed.
Finished it. Can you get some more?
Oh, I know.
Oh, yes.
No. That was great.
So what did you say? I was.
Oh, okay.
Hey, Dave. It is. Good morning. How are you?
Good to see you.
Good to see you.
They do have a big trip.
I had to drive a cover today.
Money. Good setup. Good setup. Good. Oh, great. No, what's great there?
Which one? Washington, that's easy. Trial.
Oh, okay. Oh, great. Good. And we've been working, in dialogue with
It is. This is huge progress.
Yeah, it seems it's, probably the issue over there is they don't actually have a subcommittee.
But I think it will have to be live. Because, the NRC has a lot more data.
It's nice to have a.
They don't need to collect the data. But there's probably also some.
And I think they're developing, so we really have to work on this kind of
But
dialogue.
I would bet
It's obviously most
30%
things
things in
if you talk to it's hard to pass things in this gridlock over there. I think the last
It's
couple
so
of weeks,
bizarre.
last couple of weeks really interesting. So it's
I'm based here. I'm a long-term DC
career.
Yeah. Well, Aaron is terrific, and my Nuclear Innovation Alliance.
I thank the gentleman. Okay, we are reconvened, and if I can find my place in my notes, we'll get started here. Thank you all for waiting for us. Okay, the chair's going to recognize himself for 5 minutes. Mr. Kotec, you mentioned that the Office of Nuclear Energy is working to address each of the major areas of H.R. 4084, including Section 7, which Mr. Rothrock actually referenced, to enable the private sector to partner with national labs. You see any major impediments for DOE to carry out the National Reactor Innovation Center as basically described in Section 7 of the bill?
Thank you for the question, Mr. Chairman. The timing is actually quite interesting. As I mentioned in my testimony, we have the GAIN initiative that we just announced last month. Through that, we're trying, I think, to address some of the things that you're getting at in your bill in terms of providing better access for companies and innovators to the set of tools, capabilities, codes, facilities, et cetera, that exist at our national laboratories. So that, I think, gets at part of it. Another thing that has been raised with us is the possibility of building privately funded reactor facilities at DOE laboratories. And we're engaged in a process right now where we're working through just what would the specifics of an agreement like that be. And so at this point, I can't say for certain that we've got these particular obstacles, but as we go through that process of working through what it would take for a private company to be able to build on a DOE site, I would suggest that we continue to work with your staff to communicate what issues may have arisen and figure out what the resolutions of those things might be.
But you don't see any stumbling blocks to trying to establish this kind of cooperative effort to?
I think broadly speaking, no. And we've been listening to, frankly, to you and to folks like Mr. Rothrock and some of the innovators in nuclear to try and address just the types of challenges you folks are working to address.
And you see the need, right?
Oh, absolutely.
Good.
Yeah, and that was really part of the motivation. I mean, a lot of the credit for the GAIN initiative comes from this larger conversation we've been having, again, with you folks in the drafting of this bill, but with Mr. Rothrock and others who want to innovate in nuclear and want to get better access to our capabilities.
Good. And Mr. Rothrock, a question for you. In your testimony, you also pointed out that the U.S. government oversight of nuclear energy R&D is required by law, and that advanced nuclear startup companies will need some degree of partnership from the federal government. And I think it was you who said, was it $1 of private money and $2 of, did you have that backwards? No, that's not the question. So how do you envision the National Reactor Innovation Center in Section 7 of this bill, 4084? How do you envision that center assisting with this effort?
Thank you. I envision it assisting very hands-on. There is, and here there's an already existing example, the Mojave Air and Spaceport in Mojave, California, 27 private companies, $3 billion of private investment on an old military base run by private enterprise, but under the auspices of the FAA. It's not exactly what we're talking about here because at a facility like the National Lab, you have people, skilled workers, you have the machines to turn the equipment, to build the equipment, to monitor the safety of it and the health physics. That's what we need. Getting a permit to create even a subcritical pile at a facility other than a national lab would be impossible in this country. So I see it being very direct, hands-on, in the lab with the private company people and the laboratory people working hand in hand to demonstrate whatever it is they're trying to prove or show. And then also having the NRC embedded in that process too, so they will not be surprised by something that's discovered.
Well, that's a good point. We're going to go to there with Dr. Klein here in just a second. But the point is that if this were a transportation bill or if this was a infrastructure building, for example, we would call this a private-public partnership.
Exactly.
And so, kind of along those same veins, and Dr. Klein, moving to you as former chairman of the NRC, what R&D capabilities do you think would be necessary for the NRC to help, as Mr. Rothrock just lined out, timely license and advanced reactor design?
Well, thank you, Mr. Chairman, for the question. One of the challenges that the NRC has is they need data to make their safety analysis. And so that's why this bill is so important, to provide the nuclear infrastructure, to provide data for which the NRC can then make a safety case. And I worry about our country losing its nuclear infrastructure and leadership.
I do too.
I'll give you a specific example. I've been asked by TerraPower to help guide them on some nuclear licensing activities for their design that Bill Gates is partially supporting. So TerraPower is a design for a fast reactor, and the fuel elements will be in there for longer than we've ever had this done before. So obviously, for any kind of licensing, whether it's in China or in the US, you need some data. In order for TerraPower to do some fuel quality studies, the only place they could go to do that work is the Bor 60 reactor in Russia. And I think that's the sad state of our nuclear leadership, that we do not have the capabilities to do some of those science studies in the US.
Well, and I appreciate you saying that. So if the NRC was actually involved from the very get-go in watching this data get compiled, would that help in two ways, with the validity of the data and timeliness, so you don't have to go back and reevaluate?
Right. It would be very beneficial for the NRC to be involved early and often.
Yeah.
One of the NRC has a very good technical staff, and I think they can make decisions, but getting the data and understanding the quality of data is necessary.
And of course, going back to my discussion with Mr. Rothrock, I would point out that actually the funding for the NRC is actually a private-public partnership in some sense of the word. So thank you for that, and I'm going to yield to Mr. Grayson.
Thank you, Mr. Chairman. Mr. Rothrock, your testimony focused on shots on goal, the idea that if you let 1,000 flowers bloom, some of them will actually bloom. And you also gave us a map that showed startup companies all over the country, dozens of them, focusing on developing fission concepts. How many shots on goal do we have funded by the federal government now in terms of fusion research, making fusion research work, making it economical and a net producer of energy? How many?
There are 7 that were on that map that are fusion specifically. And there are 2 that I'm aware of that are privately financed. The rest are government.
Okay, and historically, what are the main investments that we've made in fusion research over time?
Well, there's the ITER project in France, which we've been contributing to, and there is the NIF facility at Livermore, which is a national ignition facility. Those are the 2 main ones that I'm aware of. There may be some smaller experiments in laboratories and universities, but that's primarily.
How much of federal funding for fusion goes to merit-based review of potential proposals that are innovative and high risk, high reward?
I don't know.
Is it a large percentage or a small percentage?
Probably, it's probably a small percentage.
Do you think it should be more?
Absolutely.
Why?
I think we should double our R&D budget everywhere on this topic.
Tell me why. Why do you say that?
Because just as you opened with the notion of many shots on goal, you've got to have a lot of ideas tested in the earliest days to find out if they have merit, and then they will eventually move forward. If they do have merit, they can seek private funding, like many fission projects have, and a few fusion projects have, and receive that funding.
Mr. Kotec, what do you think?
Thank you, sir. My office, of course, doesn't fund the fusion energy research in DOE. That's a different part of the organization, so I'm not intimately familiar with the funding. With respect to your specific question about how much goes to innovative concepts, well, I don't know off the top of my head. I can certainly work with my colleagues to get you an answer on that.
Dr. Klein, you want to weigh in on this?
Anything that enhances U.S. leadership in nuclear technology is money well spent. If you look at one of the programs that actually was funded by DOE that was a game changer was the Genome Project. And so the Atomic Energy Act was what let them do that funding. And so we've all seen the results of that. I think the federal government has a responsibility to do high-risk research that then can be turned over to the private sector for innovation.
All right, back to you, Mr. Rothrock. I understand that there was a milestone reached by Tri-Alpha Energy recently and that you're familiar with that. Can you explain that, please?
Sure. For fusion reaction to occur, you need to contain the hot plasma, and you need to have it at a sufficient temperature that the nuclei will combine. Their milestone event was the containment of plasma at will and in a controlled environment, and that is a huge milestone in the plasma universe.
So tell us what the next step would be.
To take that same plasma and heat it up to the point where it will ignite, and the nuclei will combine, creating the fusion process.
Is there a timeline for that?
Yes, probably 5-6 years from now.
Why so long?
Well, it takes about a year and a half to build a machine and another year and a half to run the data, and then probably another year and a half to get it vetted by the world science community. Part of Tri-Alpha's efforts recently has been to get the data out into the science world to have it vetted and confirm that it is in fact good.
All right, let's suppose that happens and it works. What does that mean for the world? What does that mean for America and the world?
Well, it's extraordinary. In Tri-Alpha's case, it is a fuel cycle that doesn't produce any neutrons, so it is basically the radiation of a hospital, which means you can build very large, high-density electric power plants without the neutron radiation issues that you face with a fission plant. It'd be extraordinary.
Is that because of the fuel?
Fuel cycle.
You want to explain that?
The fuel cycle of Tri-Alpha is a proton-boron reaction, which produces 3 alpha particles, which are helium, with no neutrons. So it uses the soft X-rays to convert to heat to make steam to make electricity. The other fusion cycles, DT, that are being pursued at NIF and other places, produce neutrons, and neutrons are they make everything radioactive.
The deuterium-tritium cycle.
DT cycle, yes, sir.
Okay. And Mr. Kotek, do you want to address the idea of what it would mean for America and the world if we had a successful fusion program?
Well, certainly as part of the administration's all of the above energy strategy, we're pursuing fusion research and a wide range of non-emitting technologies. And so, any advancements towards that would make more non-emitting technologies available in the commercial marketplace would be a great thing.
All right, Dr. Klein.
I think if we can make commercial fusion, it'll be a game changer. The question will be, can we do it economically, and what are the technical issues to overcome?
What do you mean by a game changer?
It would be providing electricity to the public at hopefully a reasonable cost with less radiation involved and an abundant fuel supply.
All right, I'll yield back. Thanks.
Thank the gentleman for yielding back. Let's see, Mr. Loudermilk from Georgia, you're recognized for 5 minutes.
Thank you, Mr. Chairman, and to the witnesses, thank you for bearing with us during the craziness getting down to vote, and I appreciate you being here. Being from Georgia with the new standards that are coming, if they continue to promulgate, which I hope they don't, but if they do, we're looking at losing a lot of our coal-fired plants, and so we're going to rely more heavily on nuclear, which we do have the first new reactors going in at Plant Vogtle, which I visited a few months ago with Chairman Weber. But Dr. Klein, you brought up something that's very interesting to me. I chair the Oversight Subcommittee, and so efficiency and management of these projects is very important. And you brought up in your written testimony, and you alluded to it in your verbal testimony, that DOE project managers, as compared to the private sector equivalents, have little incentive to control project costs, which of course overruns can hinder the advancement of future projects, also because of the lack of funds. And we all want to be very efficient, and I agree with you on that. But on the other hand, in a previous hearing regarding nuclear research and development, is the testimony was that there's in some cases too much regulation, and that stifles innovation. And so I wondered if you could just opine on where is that balance? What are some of the specifics that you would like for us to implement in Section 7 to strike that balance? And I agree with you, too much regulation or too little oversight can cause waste. Too much regulation causes waste as well, if you would, sir.
Sure, thank you. As a recovering regulator from the NRC, one of the things that I think makes the NRC a better regulator is having to deal with the backfit rule, where you do have to make a risk-benefit choice. I think something like a risk-benefit backfit rule would help DOE in their project management. Regulators always tend to be conservative. If 5 guards are good, 10 are even better, so why not do it? So there needs to be a check and balance, and I think on DOE, if they had the incentive to do, like a backvet rule, to do a risk-benefit analysis on the regulatory changes, I think would help the American people.
Thank you. Mr. Kotek, would you, or Mr. Rothrock, also like to weigh in on this at any stage if you have anything to add?
Sure. With regard to the regulation of the, getting through the design cycle and the review, an issue that all the startup companies that I've interviewed face is that it takes a lot of money, a long time, and it's not predictable. We have in our government, FAA, FDA, there are very dangerous processes, very things that could be scary technologically, but we have processes in place to get those through to a point where the public, where they're safe for the public to use and they benefit the public. That system does not exist at the Nuclear Regulatory Commission, and it needs to be addressed. And some of us are working with various people. Chairman Burns is well aware of this. I've spoken to him personally about it. But it is something very important to build a risk-based analysis, technology-neutral analysis rather than prescriptive work.
Mr. Kotek?
Yeah, thanks. With respect to that particular issue of regulation, one of the things that we're doing in our organization is working with the Nuclear Regulatory Commission to help them as they prepare to receive applications for advanced reactors. So they've got extensive experience dealing with water-cooled reactor technologies, but not really with molten salt or metals, et cetera, or gas-cooled reactors. And so we've been working with them over the last several years to develop generic design criteria that could be used in the licensing of advanced reactor types. Been holding workshops with them, had a very successful one back in September. We'll hold another one early next year to try and help them understand what are the issues that they're going to have to confront as they start receiving some of these advanced reactor designs. And we found that the NRC to be a very willing participant in those discussions under the leadership of Chairman Burns.
Okay. Mr. Chairman, with that, I yield back my remaining 30 seconds.
I thank the gentleman, and my good friend from Texas, Mr. Vesey, is recognized.
Thank you, Mr. Chairman. I wanted to just ask you to describe the difference between the process here to bringing a reactor online versus, let's say, in France. I've always have heard that sometimes it may be easier in that part of Europe to bring a reactor onto the market versus in America. And can you kind of explain the differences?
That's a very good question. One of the challenges that we have in the United States is that we have a lot of vendors and a lot of different utilities. France has the advantage of having one vendor, government-owned, one utility, country-owned. And so therefore, they have a standardized plant. And what they do is they will wait 10 years before they will come out with a new model. So all the advances that they will make, they will bucket those until they come out with their next model. So really, the France technology is developed out of Westinghouse's technology. So it's originally rooted in U.S. technology. But their standardized plants, one vendor, makes their licensing more simple. I think in the U.S., we can do it just as fast once we get these standardized reactors through the design certification and the building process like we're doing for Vogtle 3 and 4.
So there's no safety issue at all with them bringing them on faster? Because I know that some people will say, no, if you bring them on faster, maybe you're giving up safety, but you're saying that there's no safety at all. It's just the process is what's different.
Yeah, it's a pre-approved, standardized process, no compromise on safety, so their reactors are as safe as ours.
You know, one of the, we have a nuclear power plant in the part of Texas that I'm from. I live in Fort Worth, and we have one down in Comanche Peak, not too far away. And, one of the issues that always comes up is storage of nuclear waste. And, of course, you can store on site or you move to a secondary location. But, of course, moving that to a secondary location has always been, controversial, whether it's, Yucca, West Texas. Like, what do you think are the long-term solutions with dealing with that problem of nuclear waste?
Well, I've visited Comanche Peak several times. That's a very nice facility, safely run. One of my most frustrating activities I had as chairman of the NRC was the pulling of the Yucca Mountain license application. My job as chairman was not to determine whether it was safe or not. We had a staff of 150 that were making that technical determination, and they never had the opportunity to finish that. That application was over 8,000 pages, referenced over 1 million pages of other additional data. And so my frustration part was that as the NRC, as the regulatory body to make the safety analysis of that case, we never had that opportunity. So that's one issue. At reactor storage is safe, having a centralized storage is safe, but we really need, as a nation, to move towards a permanent disposition program. It's not a safety issue, it's a political issue.
So how, for instance, like how long could a plant, like let's say Comanche Peak or another plant around the country, safely store spent fuel?
You could safely store dry cask storage for over 100 years. So it's not a near-term issue, but it is one in which I think as a nation we need to progress towards a permanent strategy. And right now we don't have one as a nation.
Thank you. Dr. Klein, thank you. I appreciate it. Mr. Chairman, I yield back my time.
I thank the gentleman. The gentleman from California is recognized for 5 minutes.
Thank you very much, Mr. Chairman. I'd like to congratulate you, Mr. Chairman, as well as the chairman of the full committee that on moving forward with this bill. And it's a very significant issue that we have to deal with, and I don't think we've dealt with it. And we've got to let ourselves get behind. I was just over in France where they, of course, get most of their electricity from nuclear energy. And they made certain technology decisions earlier on that gave them that capability. And they have not had the ups and downs and the problems with being dependent on energy from another country. About the issues we were just discussing in terms of storage, do we not have the technological capability now of building nuclear reactors that will not have this leftover waste? And in fact, I've been told by several major companies that it is now within our capability to build nuclear power plants that actually eat the waste that we've had from the past ones. Why are we focused at all on building anything that has a leftover waste problem when we have the capability to do something else? The gentleman was shaking his head. Go right ahead.
Thank you. Yes, we do have that capability. There are a number of advanced reactors in design today by startup companies that I showed earlier that would like to burn up all the spent fuel. There's an enormous amount of energy stored in those pools at these existing reactors. And the site already exists, the fuel pool is there. Why wouldn't we build a reactor just to consume all that fuel?
How much would it cost? I mean, I was here earlier sorry, we had to go out and vote and all these other things. How much would it cost? I noted the $1.5 billion that's being invested in the private sector in this whole goal. How much would it cost to build one of these? I know about 5 or 6 different, high temperature gas cooled reactor, pebble based reactor, and thorium reactors. All they've all been to me, and I like them all. I don't have an expertise like you fellas do enough to tell which is best. But why are we not? First of all, how much would it cost to build a prototype of one of those small modular reactors that does not have the waste problem?
Boy, I need to be careful here, but we've done that estimate at the company Transatomic, and we think it's about 5 years and $300 million. We could demonstrate that capability.
So 5 years and $300 million. Would we have a prototype then, or is it just demonstrating
demonstrate the ability to burn spent fuel and to consume it?
Yeah, Mr. Chairman, again, if we're going to have a future in nuclear energy, let's not build light water reactors that have more waste and can't handle the major problem that we have when we have the capability of moving forward. But again, building couple $500 million or something like that to build that prototype, that maybe is there a way we can facilitate those people in the private sector to move forward with that type of expenditure, whoever?
We've had numerous conversations with Idaho National Lab about putting that prototype there, what it would cost, what it would take. Mr. Kotek's department is well aware of some of these ideas. These are early conversations, but we think it's quite doable.
Yeah, Congressman, if I could add to that, we certainly are in discussion, have been made aware of companies that are interested in potentially working with the Department of Energy to build prototypes, for example, on DOE sites. We're going through the process now of understanding just what would the contractual relationship need to look like. With respect to the
Yes, go right
if
ahead.
I could, with respect to the question about waste, I do think it's important to note that you never make all of the waste go away. Even if you have a full recycle system where you're recovering all the uranium, plutonium, what we call minor actinide elements, you still have some very long-lived wastes that are left. And so we will always need some sort of a long-term waste isolation capability to support nuclear.
Just but not at the scale.
I understand. I just want to felt I needed to make that clarification.
If the scale was smaller, this would not be as great a challenge by definition. And look, we need to move forward and not based, again, light water reactors, they've been around since before I was born. We don't need to move forward and facilitate the production of nuclear reactors based on that when we have other options. I mean, I understand even, is it Lockheed now that has a possibility of a fusion reactor, a small fusion reactor? Is that, has anybody looked at that?
They do. It's an experiment at this point, and it's very small.
Right?
Yeah.
Is that real?
I don't know.
I've
not spent that much
Any
time.
comments on this? Or just
I don't know.
As some kind of a dream that isn't attached to reality there. Again, there's we have some new weapon systems right now that we need a small modular nuclear reactor in order to make those weapon systems work. And I sure hope that's one part of the formula. But the other part of the formula is our grid. The grid is vulnerable. And if we can have small modular nuclear reactors, we can take the public off the grid. We can have, each community can have their small reactor, and you're not going to have this vulnerability that we have now with some solar surge or some nuclear explosion up in the atmosphere. We need to move forward in a rational way, and I'm afraid that we're moving forward with big companies now that basically want to build what they've already built. And I hope that's not the case. Well, thank you very much, Mr. Chairman. Thank you for leading the fight to put this bill through and get this passed.
Well, I thank the gentleman. Does that mean you've signed on to our bill? All right, thank you. I appreciate that. I want to thank the witnesses for their valuable testimony and the members for their questions. The record shall remain open for 2 weeks for additional comments and written questions from the members. This hearing is adjourned.
I don't know. I was laughing too. I don't know. Good fight. I'm on record.
Yes. You should get. Thank you, sir.
Great to see you again, and thank you.
Keep the ideas coming.
Oh, man, absolutely.
We're trying to listen to you guys.
You're doing great.
Thanks.
Like I say, it's a business plan with ambitions. I love it. You got to start with that. You got to have a vision. So good job, man.
Hi.
Oh, yeah.
John Kotek. Thanks for being here.
Congressman, Fort Worth?
In my view, DOE has the authority to build and license reactors under the Atomic Energy Act. Oh, do you really? I think whether that's, I represent all the neighborhoods around.